previous lecture, we saw that the fundamental idea behind a virtual machine is to abstract the hardware of a single computer into several different execution environments, thereby creating an illusion that each separate environment is running on its own private computer. So this lecture is a continuation of the previous one, and we will continue discussing some more features and benefits of virtualization. So we have already understood that in virtualization, the host system is protected from the virtual machine because of a layer of indirection in between, just as virtual machines are also protected from each other because they are completely independent and isolated. So one common feature of most virtualization implementation is the ability to freeze or suspend a running virtual machine. Virtual machine monitors, that is the hypervisor, also allows to make a copy or snapshot of the virtual machine, a guest virtual machine. This copy can be used to create new virtual machines or to move a virtual machine from one machine to another with its current state intact. So let us say user had a demand, and to cater to that demand, 5 virtual machines were created and allocated to that particular user. Now, due to increase in the requirement demand, the user requests for 2 more such virtual machines to be created. So this can be easily done, as hypervisor will simply copy the already running virtual machines to create a new virtual machine for the same user very quickly. Or let us take another example. So the user is being catered to through virtual machines by a particular server in some location, and due to some reason that virtual machine needs to be moved to some other location or some other server. So this can also be easily done because the virtual machine can be copied, or just the snapshot of that virtual machine has to be virtual machine is nothing but set of files. So copy of those files has to be just sent to that particular server or location wherever it needs to be moved. Next, a virtual machine system is a perfect vehicle for operating system research. So why do we say so? Because normally changing an operating system is a very difficult task. Operating systems are very large and complex programs, and change in one of the part may cause bugs in some other part, or may interfere with other parts of the operating system. So virtual machine, because they are isolated and it does not affect it is an emulated environment. So in that, the operating system research can be easily carried out. Another major advantage of virtual machines in production data center use is system consolidation. So let us understand this, that what is system consolidation? Basically, it involves 2 or more separate systems and running them in a virtual machine on one system. So what happens here is that let us say that there are many lightly used systems. So such systems can be combined and to create one more heavily used systems. So this results in resource optimization. So basically, it's a physical to virtual conversion. Such physical to virtual conversion results in resource optimization. Now, virtualization can not only improve resource utilization, but also resource management. Now, through live migration. So what is live migration? It is moving a running virtual machine from one physical server to another without interrupting its operation or active network connection. So we have, if you have a virtual machine which is running on one server, and for some reason you want to move that server which is serving a particular user to another server, it can be easily done through live migration. So live migration, the user will not experience any interruption in the service. So for so this can be used if a server is overloaded. Live migration can thus free resources on the source host while not disrupting the service which is being provided to the user. Similarly, if the hardware has to be repaired or upgraded, then the virtual machines can be migrated to other servers, and then they can also be migrated back once the repair and the upgradation is done. And this occurs without any downtime or without interrupting the users. So this is called as live migration. Next concept or feature is templating, which is one standard in which a standard virtual machine image, including an installed, configured, guest OS and application, is saved and used as a source for multiple running virtual machine. So if so, what does a virtual machine contain? Virtual machine, if you look at it, it has nothing but a guest operating system and many applications which are running. So either user can start from the scratch, install it their own operating system, and then their own desired applications which are required to them, or they can take a template. So template is already an operating system is installed and there are some applications which are already there, and the user can add more applications as per their own requirement. So this is possible because of templating. So basically it is a management tool. So, and finally, cloud computing is made possible because of virtualization. We have already said again and again, I'm reiterating that virtualization is the core technology for cloud computing. So it is because of virtualization that resources like CPU, memory, storage, and input-output ports are provided as a service to the users through network, that is internet technologies. Okay, next in this lecture, let us look at some requirements for virtualization which have been defined. So the virtualization requirements call for following. First is fidelity. It says that a virtual machine monitor, that is the hypervisor, should provide an environment for programs that is essentially identical to the original machine. Second is performance. That is the programs that are running within the virtual machines. They should show only minor performance decrease, if any, as if running compared to running on a native or their local machines. Next point is safety. The virtual machine monitor should be in complete control of the system resources. So these requirements were actually established by Goldberg and Popek in 1974 as three properties that have to be satisfied by a virtual machine monitor. So these three properties are stated as: first is equivalence. So equivalence is that a guest running under the control of virtual machine monitor should exhibit the same behavior as when it was executed directly on top of a physical host. That is, a user should not experience any difference in the performance when it is running the applications on their native systems, native hardware machines, or they are running on virtual machine. They should experience the same kind of performance. So this is called as equivalence. Second is resource control. The virtual machines, they should be in complete control of the virtualized resource. Now, this is very important because this leads to the security aspect also. If the virtual machine monitors, they are in complete control of the virtualized resources, then they will be able to allocate or project whatever hardware requirements, project the resources as per the hardware requirements of a particular user in that particular virtual machine. And they will be able to maintain the isolation of virtual machines. So virtual machine monitor or the hypervisor has to be in complete control of the virtualized resources. Third is efficiency. So let us see this. So it says that a statistically dominant fraction of machine instructions should be executed without intervention from virtual machine monitor. Okay, so let us understand what does it mean. The instructions, the machine instructions which are there, they are broadly classified into two classes. One is non-privileged instructions and another is privileged instructions. Non-privileged instructions can run natively on the hardware, providing the same performance for the guest as that of native application. But on the contrary, privileged instructions cannot run directly on the hardware. They are run via virtual machine monitor. So those instructions go to virtual machine monitor and then it will be executed from there. So basically, this causes delay in execution of those instructions. So then the virtual machine monitor will run slow compared to what it would have compared to natively. In addition that there are many virtual machines which are running, and there is a hypervisor which is taking care of all of these. This can further slow down the virtual machines in an unpredictable way. Therefore, it is important that a dominant fraction, a major fraction of the machine instructions should be executed without intervention from virtual machine monitor. Only some privileged instructions which actually try to modify or change the hardware, they should go via virtual machine monitor, that is the hypervisor. So these were the three properties that were established by Goldberg and Popek in 1974, and they have to be satisfied by a hypervisor, any hypervisor. So in the next lecture, we'll look into more details about what a hypervisor is and what are the types of hypervisor. Thank you.